Hi, friends. Today we're going to talk about completing the square. I'm going to forewarn you, you might have to watch this video once or twice, um, but we're going to talk about completing the square. Now, completing the square is how we can take a quadratic in standard form and write it in graphing form or vertex form from last week. So let's go ahead and we're going to think about this. We're going to go back to algebra tiles to help understand what completing the square means. So I'm going to take this and think of it as algebra tiles. I would have an x, 1x squared tile, and now I would have 8x tiles. Now with 8x tiles, if I'm going to create a square, that means I need to split them up evenly because with a square, every side has the same length. So that means I need to take half of 8. So I'm going to have 4x's here, and I'm going to have 4x's here. I'm doing my best to draw this. I know it won't be perfect. All right, so I've dealt with my 1x squared. I've dealt with my 8x's. And now what I would have is I would have 10 unit tiles. So if I took these tiles to start building a square, I would be short. I would be short. And I would be short how many? Well, I'd be short 1, 2, 3, 4, 5, 6. I'd be short 6 tiles. You can see them right here. These would be my 6 tiles I'm short making the square. Now, remember that this is equal to y. So this is kind of our visual of this equation at the top. So y equals all of this. Now, if I added 6 tiles to complete the square, I have to add 6 tiles to the other side of the equal sign. Remember, with an equation, we want to keep things balanced. If I do it on the right side, meaning I added 6 1 tiles, I have to add 6 1 tiles there, which essentially leaves me with y plus 6 equals my square. Okay, so let's move on from there. I have y plus 6 is equal to what? Well, I have a square, and the dimensions of that square is x, 4, x, 4. So it would be x plus 4, x plus 4, which is y plus 6 equals x plus 4 squared. Now, when we look at this, we can start to see that vertex form kind of taking shape. And my last step here, because I like equations to be y equals, I'm going to take that 6 away that I added. And I'm going to take it away on this side, which will leave me with y equals x plus 4 squared minus 6. And this would be the same equation in vertex form. Now, I might be a little confusing. We're going to look at it one more time, thinking of it kind of in a different context, but the exact same problem, still completing the square. Here, I'll do it on the separate sheet of paper. So we're going to start with the same problem. We had y equals x squared plus 8x plus 10. And this way might lend us to maybe a shortcut to do this without actually drawing a square. So if I were to do this, I'm going to follow the same context, right? So I would have x squared. I'm going to split the middle term up, half and so I have equal halves. So again, I have 4 x tiles and 4 x tiles. So nothing has changed so far. But now I'm going to do something just slightly different than before. Instead of taking these 10 1 tiles and putting them in here, I'm going to set them to the side. So I'm going to set my 10 tiles to the side. I'm not going to use them. So what that tells me is I would have to take kind of a brand new 16 tiles. So let's say right here I put brand new 16 ones. That means I've added 16 tiles. Now, this is where it gets a little dicey. Let's pretend this is still y equals. If I add 16, but then I immediately take 16 away as well. So like plus 16, take away 16. I've essentially added 0. I've kind of added it and taken it away right away. But by showing it here and here, I've completed my square. And since I completed a square, just like before, I have this. X plus 4 squared. Remember, x plus 4 times x plus 4. And now back here, I would have plus 16. Whoa, not plus 16. I would have plus 10 minus 16. So that's just coming down. So wait, what did we gain by that? Well, what we gained was we're able to write this part. And we're allowed to think if we had that 4 squared, made the 16. We took that 16 away, which means we didn't change the formula or the equation at all. And we still equal y. So we should get the same vertex form. Y equals x plus 4 squared. And now I have plus 10 minus 16, which gives us minus 6 when it's simplified. And if we look back but before, that's the same vertex form that we got before. So that is how we can complete the square using kind of that visual piece. And then in the next video, we'll look at how can we do this maybe without the visual. But it's important to understand where this word completing the square is coming from.